Okay everybody, so in this video I'm going to be giving you guys a few more examples in determining whether something's homotopic, enantiotopic, or diastereotopic. So in this first example here, we want to know if these two hydrogen atoms are homotopic, enantiotopic, or diastereotopic, and it turns out that they're actually enantiotopic, but we're going to be justifying this using the substitution test, okay? So this time we're going to be replacing the hydrogen atoms with the deuterium atom, with D or 2H, okay? So when you do the substitutions, you get either this compound or this compound, all right? And then we also have these chiral centers, right? We have 4 different substituents, 4 different groups. If you guys want a review on chiral centers and priority rules, you can check out one of my previous videos for that, okay? So now that we have our chiral centers here, we're gonna determine if they're R or S. So hydrogen has the lowest priority number because it has the lowest atomic number, so it has the lowest priority of 4. Then comes deuterium, it has an atomic number of 2. And now to find out the priorities 1 and 2, with 1 being the highest priority, we're going to be looking for the point of first difference, right? So we have carbon here, carbon here. Next carbon, we have carbon, carbon. This carbon has 2 chlorine atoms attached. This carbon has 2 hydrogen atoms attached. Chlorine has a higher atomic number than hydrogen. Therefore, this side, this substituent over here, has a higher priority than this substituent. So therefore, this substituent has the priority of 1, the highest priority, and this substituent has the priority of 2, okay? And we did this looking at the point of first difference. So we have 1, 2, 4, and 3 over here, okay? Now we're gonna stick our sum in the direction of the lowest priority. In that case, it's hydrogen, okay? So hydrogen is sticking out of the board. So now we're gonna curl our fingers. So we go like this, and it goes from 1 to 3 to 2. 1, 3, 2, 1, 3, 2, 1, 3, 2, 1, 3, 2. That is not the natural order of counting, so therefore our chiral center is S. Now we're going to go to this molecule. We have 4 for hydrogen. The lowest priority has the lowest atomic number of 1. Then we have deuterium. Next, we're going to be looking at the point of first difference, just like we did in this one. So we start here at our chiral center. We go 1 carbon out. Still the same thing. This is 2 hydrogens attached. Also here, we got 2 hydrogens attached. Next, we're going to be going to the carbon afterwards. So here we have a carbon, 2 chlorines attached. Here we have a carbon, 2 hydrogen atoms attached still. So here we have our point of first difference. What has the higher atomic number, chlorine or hydrogen? The answer is chlorine, so therefore this substituent has the highest priority of 1, while this substituent has the next highest priority of 2. Okay, and that's how we did that. We did it using point of first difference, okay? So now we're going to do the right-hand rule again. Hydrogen sticking out, stick our sum out of the page, then we curl our fingers. So we curl it like so. It goes from 1 to 2 to 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That is the natural order of counting, so therefore our chiral center here is R. Okay, so we have S here, we have R here. We only have 1 chiral center. For this compound, we have only 1 chiral center for this compound. So we have S here, we have R here. Therefore, these 2 compounds are enantiomers, and therefore these 2 protons are enantiotopic. Okay? Now we're going to go to our next example. We got this compound over here. We have this hydrogen sticking out of the paper, and we have this hydrogen sticking into the paper. Okay? We want to know if these 2 protons are homotopic, enantiotopic, or diastereotopic. And they are in fact homotopic, and we're going to see this using the substitution test. Once again, just like in this example, we're going to be replacing with the deuterium atom. Okay, you do the replacements, and you have these 2 compounds over here. Now, how do we know if these 2 are the same? You know that they're the same if you can flip this one. So let's say we have this molecule like that, and you flip it like so. Just flip it like that. Just flip, just like that. Okay. So this deuterium atom here is going to be sticking into the paper. But once you flip it like this deuterium atom is sticking out of the paper. What's another way to visualize this? Okay, so here I have my mechanical pencil, the eraser. So let's pretend the eraser is the deuterium atom in this case, pointing into the paper. And let's say I flip it, just like I flipped it, just like that. Let's say I flip it like that. So now my eraser, or the deuterium atom, is on the left side, and it was on the right side before. Remember, I flipped it, so it's on the right side here. I'm flipping it, so now it's on the left side, and this time it's sticking out of the paper. It's sticking out of the paper towards you, the viewer. And in that case, then you denote it like this. So it's the black solid wedge, meaning it's sticking out of the paper, okay? And you can make a similar comparison for hydrogen as well, okay? So as a result, these two molecules are the same molecules because you got deuterium, deuterium, hydrogen, hydrogen. You got two chlorine atoms, one sticking into the paper, one sticking out of the paper. You got both deuterium sticking out of the paper, both hydrogens sticking into the paper. They're the same molecule. They're the same thing. So as a result, these two hydrogen atoms are homotopic. All right. Now, example number 3. Now we're not going to be looking at hydrogen atoms. We're going to be looking at methyl groups. Are these homotopic, enantiotopic, or diastereotopic? We're going to justify their enantiotopicity using the substitution test. So let's look at this. This center is actually achiral at first, okay? Because you got hydrogen here, you got chlorine here, and then this substituent is the same as this substituent. So therefore, this center right here is achiral. But once you do a substitution, you produce a chiral center. You produce a center that's chiral, okay? Just like I discussed in the previous video. You start with your original compound that has an achiral center. Once you do the two substitutions, you end up with two compounds, each of which is chiral. And then you have to determine whether the two chiral compounds that you now have, whether they're enantiomers or diastereomers. And if the two compounds are enantiomers, then the two groups that you're comparing at the very beginning are enantiotopic. So we're going to do the substitution test with deuterium again. We're going to replace this methyl group with deuterium. We're going to replace this methyl group with deuterium over here. Okay? So chlorine has the highest atomic number, has the highest priority of 1. Hydrogen has the lowest atomic number, therefore the lowest priority of 4. Now we go to the point of first difference. Okay, so we start at the center right here, at this carbon center. We go 1 carbon out. Same thing. Second carbon out. Same thing. Next, we go one more step. We have deuterium, we have methyl. Deuterium has an atomic number of 2, while methyl, which contains CH3, so it contains carbon, and carbon has an atomic number that is higher than 2. So therefore, this has a priority of 2. This has a priority of 3. Okay? And then we can do the right-hand rule. So hydrogen sticking out. So some sticking out of the paper. Curl our fingers like that. It goes from 1 to 3 to 2. 1, 3, 2. 1, 3, 2. 1, 3, 2. So that is not the natural order of counting. So then you have a chiral center that's S. Okay? Next, we're going to go to this one. So you have chlorine, hydrogen, deuterium, methyl. You do the same process again. Hydrogen sticks out. Right-hand rule. This time you go 1, 2, 3, 1, 2, 3. That is the natural order of counting. So therefore, your chiral center is R. Okay? So you have S and R. These two are enantiotopic. Okay? These two methyl groups are enantiotopic because these two compounds are enantiomers. Okay? Finally, let's go to example number 4. So these two hydrogen atoms are actually diastereotopic. We will justify this using the substitution rule, the substitution test, by replacing with the deuterium atom. So you replace this hydrogen with deuterium, you get this. You replace this hydrogen with deuterium, you get this at the bottom, okay? You're going to end up with two chiral centers because you have a chiral center here now, okay? ClH, methyl, and then you have all this mumbo jumbo, okay? And then you have two chiral centers right here as well, okay? It can be a little bit difficult to see, but you should have two chiral centers, two centers that are chiral. So let's go to 4. Okay, so in 4, you're going to have chlorine has the highest atomic number, therefore has the highest priorities, and hydrogen has the lowest atomic number, lowest priority. Go to point of first difference, so carbon. Here you're going to have 2 hydrogen atoms. Go to this carbon, you have deuterium and hydrogen. This is the point of first difference. So you have a deuterium here, and you have a hydrogen here. You have 2 hydrogens here. Deuterium has a higher atomic number than hydrogen. So therefore, this mumbo jumbo is going to have a priority of 2. And then this mumbo jumbo is going to have a priority of 3. Now, put your thumb in the direction of hydrogen, points out of the paper. Curl your fingers, it goes from 1 to 2 to 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. That's the natural order of counting, so therefore this chiral center is R. But this chiral center remains the same. It's 4R here, it's going to be 4R here. We have 1, 2, 3, 4R, 1, 2, 3, 4R. Same thing. Now, if you want to work out the chirality, you have deuterium here has the atomic number, has the atomic priority of 3. Hydrogen has the atomic priority of 4. Then methyl has the priority of 2. And then this mumbo jumbo that contains chlorine has the highest priority of 1. And you can make a similar analogy here. This mumbo jumbo that contains chlorine has the highest priority of 1. Then comes methyl because you have carbon here and that has an atomic number of 12. Then comes deuterium, atomic number of 2. And then comes hydrogen, atomic number of 1. Lowest atomic number, therefore lowest priority. You do the right-hand rule. Let's do it for here. Hydrogen pointing into the board. So you go from 1 to 3 to 2. 1, 3, 2, 1, 3, 2. This is S. Right-hand rule here. Hydrogen's pointing out of the board this time. You go 1, 2, 3, 1, 2, 3, 1, 2, 3. Just like that. So this is R. You have 3S, 4R, 3R, 4R. Therefore, these two compounds are diastereomers because even though you have opposite letters here, you have S here, you have R here, these letters do not change. And in order for two compounds to be enantiomers, all of the letters have to switch, okay? So if it was 3S4R and then 3R4S, they would be enantiomers. But in this case, 4R4 are the same between both compounds. So therefore, these two organic compounds are diastereomers, and therefore these two hydrogen atoms are diastereotopic, okay? And once again, if you guys are still confused about the whole topic about chiral centers and priority rules, please do feel free to check out a previous video I made on that. And I hope these examples did help you guys in your endeavors of spectroscopy and in OChem 2. Thank you for watching.